I am. Okay, so what you're going to have to do today is multiply and divide rational expressions, actually, because that's what it is. So I'm going to give you x cubed. I cannot see this. I'm sorry. A rational expression, remember, is a polynomial over a polynomial, right? We just got done graphing them. So I have x cubed minus 5x squared minus 24x and x cubed plus x squared minus 72x. So your directions on this say write equivalent expression. That's what your directions would say. So what should you do? Factor. Factor and reduce, right? So work on factoring that while I'm getting rid of my stuff underneath here. So I can factor an x in the numerator, right? So then I have x squared minus 5x minus 24. Does that factor? Yep. So x minus and x plus x minus 8 and x plus 5. And then denominator and x again, right? So x squared plus x minus 72. Can you factor that?
Yes. X plus 9, x minus 8.
Okay. And what do you do after that? Yes.
Where did you get plus 5? Would it be plus 3?
Oh, yes. Bless you. Yes, it would be plus 3. You're correct. Because I saw the 5 and wrote 5. Okay, now what? Reduce. Thank you. So I'm going to reduce. The x's can reduce, correct? I hate reducing x's because I'm like, they're stars. They're... What else?
X minus 8.
X minus 8 can reduce.
And x plus 3, x plus 9.
They cannot reduce
Oh,
because they're a quantity, right?
Yep.
So, and if you need to put those parentheses so you remember, do it. Because when it's a quantity, unless the whole thing can reduce, nothing can reduce. Is that it? Yes?
Yeah. That was really
So the first was, and the last, those are equivalent expressions. Have you been doing that? Yep.
Yeah, all we're doing. I wish.
Basically. Okay? So then it's going to say simplify. Okay, so simplify 4x, 4 minus x squared over x squared plus 3x minus 10.
Which this is a completely different problem.
Yep. So this one said an equivalent lent expression. This one says simplify. Do I do anything different?
Yeah, you have to transfer the x over to where the 4 is.
Don't have to. It can stay there.
Well,
It's negative. So if it's negative and I leave it there, don't I have a difference of squares? Yeah. So I'm still going to factor, aren't I? I know it's weird to have the x behind, but then you don't have to factor out a negative and all that fun stuff. Okay. And I'm going to show you something. Can you factor the bottom?
5 and 2.
5 and 2. So x plus 5 and x minus 2. So here's your trick. Because you want to reduce this and this, correct? But are they exactly the same? No. So what you can do with this right here is you can rewrite it as negative x plus 2. That's a 5. Evidently my 2s are 5s today. Or my 3s were 5s on the last one. Okay. Now I have negative x plus 2. Could I factor out an x? I have a negative?
Yes.
So I would have negative x minus 2 and 2 plus x, or that one's easy to change around, right? 2 plus x, I can just make it x plus 2. Am I still on the screen? Okay.
Yep.
Over x plus 5 and x minus 2. Now, can I reduce? Yep. But don't forget your what hanging out here? Negative. So I have negative x plus 2 over x minus, or x plus 5. And if you want to put those parentheses around there, you're more than welcome to do so.
Can I have homework?
Just wait. We got a couple more examples. Couple more.
This is when it gets hard.
Okay. So is this any different than what you had to do in order to graph? No. Okay. So I don't think we need any more examples with this because we know we need to factor, and we need to reduce, right? Okay, so let's look at
Can you leave
multiplication.
that up there real quick?
Yep.
It's multiplication. Dividing, right?
Don't think that's dividing.
She said multiplication.
Well, look at the sign.
It's a dot.
And I absolutely hate that there's a dot there. Are you done, Ainsley? Can I move it up? Okay. So, but we're going to go to multiplying. I hate that there is a dot. When I write this on my paper, I'm only writing the dot because the book is going to have a dot. And I'm going to show you, you probably want to do instead of the dot. Because we all get lazy and then they look like negatives and then we're confused and the world comes to an end.
What are you talking about?
So instead of putting a dot, I put, guess what? Parentheses. So I'm multiplying rational expressions, but I'm multiplying fractions, correct? So we have rules when we multiply fractions. We can reduce up and down and what? Diagonally? Okay, so what do we have to do to all this? What did we have to do first? Factor. So what do we have to do to these? Factor. So I'm assuming we all want to do x plus 4x minus 4, right? And you guys realize that I can make this one big fraction right here? Can't I? Okay, so then I have x squared plus x minus 90. What is that frac?
You could negative 9 plus 10.
Y'all good with that one?
Yeah.
Okay. So x plus 10 and x minus 9. And I could make it one big fraction because it's just multiplication, right? Okay, so the denominator. Do you guys want to switch this around right here?
Yeah.
Do you want to do that?
Yes.
Okay, so that would be negative, and if we factor out a negative, because it'd be negative x plus 9, it'd be negative x minus 9, wouldn't it?
Is that a 9 on the bottom or a 4?
No, it's not squared. What?
On the bottom, is that a 9? Yes.
This one?
Yeah.
Where are your glasses?
At my house?
Okay, because that is clearly a 9,
I
Missy.
swear I saw a 4.
Okay. So
10 and
then I
4.
have the factors of 4. What?
10 and 4.
10 and 4. So x plus 4 and x plus 10. And now what? Reduce. And everything I reduce reduces to what? 1. And you guys need to remember that because you're making them zeros and that's not right, is it? And don't forget the what in the denominator? Negative. So is there anything left in the denominator besides 1? No. So I just have negative x minus 4. So is multiplication really any different than simplifying? No. Do you want to do one on your own before we go to division?
Sure.
Okay. So I have
Get it, Kaizen, because I know you're in trouble.
x plus 3
Exactly.
over 4x. And I'm just going to put parentheses, not dots. 3x minus 18 over 6x plus 18 times x squared over 4x plus 12. Does it change anything that I just gave you 3? No. Can I start? You guys okay if I start?
I just wrote down a result.
Well, start factoring. The first thing you do is factor.
I don't know how.
You don't know how to factor. We failed that test.
Yeah. That's why I failed.
Oh. Did you guys get x times x minus 6 over 32x plus 3?
No.
Because I got 4 and 4 and 2.
Oh yeah, I was wondering.
Wait. What?
You good, Jaden?
No.
What? What's wrong?
What did you do it right here?
What did I do at the end? What I had left was x minus 6 and 1x because there was an x down.
The two.
The what 2?
I think she's talking about
The squared?
Yeah.
There's 2 x's here and there's 1x down here. So 1x could reduce.
She took an x out of the x.
Because it's basically x squared over x. Okay. So how'd it go, okay?
Yeah.
Now, one thing I did forget is they're going to ask for your excluded values or the domain. Okay? I would rather you write it as a domain. So x cannot equal, now remember, x cannot equal any of the zeros of the denominator, whether we reduced it out or not. Got it? So what can't x be here?
4.
No.
2.
4 times what? X. So what can't x be?
Negative
0. Thank you. It can be negative 4 because it's multiplication. So it can't be 0. What can x be here?
6.
Nope.
2.
Negative 3.
Guys, set your problem equal to 0. This is what I said, your algebra. You weren't doing your algebra. So
-3.
-3, and I should have them in order, but,
-3.
and -3. So I already have it once, right? So it can't be that. What about on the first one? X such that X cannot be, what can't it be here? Not -9. 9, because you had a negative X. So it can't be 9. And what can't it be on the other two? -4, -10. Anytime you have stuff in the denominator, you should think about the domain. Okay? So you good on division? I mean, multiplication? Good? Okay.
So it's 9, -11, and -10?
No, it's -10, -4,
Oh,
and
that 4 looks like an 11.
Yeah, it's kind of a long, and it's squished. And if it's me, I'd erase them and rewrite it in order. Okay, so now we got to do division. So I got to ask you, if I have 7/5 divided by 6/15, how do I divide fractions? I multiply by the reciprocal of the second, correct? So this would be, reciprocating this, would be 7/5 times 15/6, correct? And then I'm back to where I was, aren't I? So the 5 and the 3, and 3 times 7 is 21 over, nope, how about 3 into 6, huh? So 3 into 6 is what? 2 or 1/2. So I get 7 over 2. Okay, so that's with numbers. So do you think it changes with these? Nope, same thing. So,
How do you get a 2 out of the 6?
because there was a 3. There's a 3 up top. It was a 3 over 6. Because you could reduce it twice. Okay, the way they write some of these, I think they write them just like a division sign.
Is this a division one?
Yeah, okay, yep. Okay, so I have 1 over x squared plus 9x divided by 6 minus x, sorry, over 3x squared minus 18x. Because sometimes they write them like I did the example over here, so I wanted to make sure how they write it. My pen, I think, is dying.
Is that how it was at first?
Yes, that's how it started. So when it's division, we multiply by the what? Reciprocal of which one? The second one. So we're going to reciprocate and factor at the same time because that's what we're going to have to do, right? Yes? Okay, so we're going to have 1 over, what can we do with this for factoring? Take an x, so x and x plus 9. I'm going to have to switch. I think this is my second pen I ran out today.
Those pens are starting to not love you.
No, it's a sign that I use them a lot.
Yeah.
Okay, well, you can't see the pencil very well, can you?
So is this the same
Yeah.
question? I'm confused.
Yes. We have to reciprocate. We haven't even started. Okay, now times the reciprocal. Wait, it's the same question as what? This was an example. That was like generic numbers. This is a whole new, this is an example.
Oh.
Okay, can I factor? We're going to move the denominator to the numerator, numerator, denominator. Do I need to do that in 2 steps, or can I factor at the same time? Okay, so I have 3x squared minus 18x.
You can factor out the 3.
And an x, and it goes in the numerator now, right? So then I get factor out of 3x, and I'm pretty sure I get x minus 6.
Yeah.
Okay? Now, on this 6 minus x, do we want to switch it? It's negative x plus 6, so we should factor out the negative, right? So negative x minus 6. So now we have a multiplication problem like we just have been doing. So I can reduce what? An x minus 6? An x minus 6? Don't forget your negative. If you're me, I circle it so I don't forget it. I really do. And I can reduce the x. Anything else? There's nothing, because this is a quantity, so there's nothing for that 3, is there? No. I'm going to put the negative with the 3, because I don't like a negative in the denominator.
How'd you reduce the x?
Because there's an x here.
Oh, alright.
Remember diagonal? Is there anything other than negative 3 in the numerator? Nope. Over x plus 9. Now, you also are going to have to do your domain. So it's kind of weird how it happens. You need the denominator after you reciprocate. Okay? So what can't x be on this one? 0 and negative 9. So I have negative 9, 0. And what can't it be over here? 6. So I have negative 9, 0, and 6. This one was in order. It was driving me nuts that the other ones weren't, so I wrote them on the bottom. So I could get them in order. After I reciprocate, is this anything different? No. Do you want to try one on your own before we go? Okay. So then I have 2x squared minus 12x over x plus 5 divided by, and they put parentheses around the examples, but they don't in the book, I don't think, the second one. Oh, they do, but on some of them, but it means nothing. X minus 6 over x plus 5. You guys far enough I can start? Or are you done already?
Yes, I'm done. Miss
You're
May.
done? Speedy?
I do these in the past.
Your domain.
Where do you get 5?
What?
I don't know.
When you divide, okay, so when you divide, you multiply by the reciprocal, yes?
Yeah.
So I factored a 2x out of here.
Then you got a 6.
I got 2x and then x minus 6, and then I just reciprocated.
Oh.
And I've,
listen.
yep. So I have x plus 5, x plus 5, x minus 6, x minus 6. So I'm left with is what?
Yeah.
2x.
Okay. And you just done that.
You took too long to get it. She woke up. Okay, questions, guys?
Do we got homework?
Yes.
Dang
It's
it.
on.